Hello, I'm Mr. Galvez. Today I'd like to introduce you to the polygon. It can be found in the My Math Volume 2 McGraw-Hill textbook under Chapter 12, Geometry, and we'll find it under Lesson 12.1. It's a very simple and straightforward lesson. And it begins by letting us know what the definition of a polygon is. So polygon is actually a word made up of two parts. Polygons is while it's poly, the root poly means many, and gon means angles. So this is a two-dimensional shape made of many angles. In a polygon, we're going to find that the figure will have to be closed in one way or another. So you have these straight line segments. You're going to have straight line segments, and there's no opening here. And also, none of the lines will be crossing. Okay, so here's a few polygons on the left side, and not polygons on the right side. Here's a shape that's opened, not closed, not a polygon. Also, if anything has a curve to it, like even Pac-Man here, that's not considered a polygon. You can't have curves or waves. No waves like this. Then you try to close it up. That's not a polygon. Okay, and then also the number of sides and angles in a polygon determine its name. So the basic polygon that can be a polygon is this closed figure using three lines and three angles. This is a triangle. If you go with four lines and four angles, now you have a quad, meaning quadrilateral. If you move on to five lines and five angles, 1, 2, 3, 4, 5. Here you have a pentagon. 6 sides, 6 angles, 1, 2, 3, 4, 5, 6. This is a hexagon. 7 sides, 7 angles, 1, 2, 3, 4, 5, 6, 7. This is a septagon. A classic octagon will have 8 sides and 8 angles, and that's that stop sign that we see everywhere. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Then if we move to 10 sides and 10 angles, 10 sides, 10 angles, 10 sides, 10 angles, that's called a decagon. Deca means 10, decagon. And we even have a dodecagon. Do means dos, 2, 10, deca. Dodecagon, that's 12 sides, 12 angles, and let me even try this. I don't even know if I can. As long as it's closed and I use straight lines, it should be okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so technically that's a dodecagon based on the number of sides. Number of sides, number of angles. Also for the polygons, we're going to find that they come in two flavors. What they call regular polygons and not regular. Regular polygons, not regular polygons, easy to distinguish, simple to distinguish. A regular polygon has congruent or equal sides, side lengths, and congruent angles. So the angles and the size of the lines, the line segments, will be equal, and it's going to look often symmetrical. For example, a classic square where every side is the same length. For example, if this is 3 inches, each side is going to be 3 inches. Every angle is the same measurement, the same degree. These are all going to be 90 degree or square angles. Back to that stop sign. In a stop sign, every angle is the same measurement. Every measurement on the length is the same measurement. I believe about 10 inches each one. So each length is going to be 10 inches. That's a regular polygon. Equilateral triangle, equal sides, equal angles. These little 2 marks mean that every angle, every length is the same length. Every line segment is the same length. So if this is 6.8 millimeters, they're all 6.8 millimeters. Okay. This is 45-degree angle. They're all 45-degree angles. A polygon that is not a regular polygon will not have the same congruent length sides, and they will not have the same congruent angles. For example, here we had a square with 4 sides. Here's 4 sides, but it's not regular. Short, long, medium, and a connector. These, if you measure these lengths, they will all be different lengths. These two might be the same angles, but these two are not. Okay. Here's a triangle. Here's another triangle. There's a long one, a short one. Okay. So if this is 10 inches, this one might be 11, and this one might be 3 inches in length. So those are not regular polygons. Here's a polygon that's not a regular polygon. I'll count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a dodecagon. Okay, it's not a regular polygon because of because they don't have equal side lengths. Even though every angle may be actually the same, 90 degrees. Okay, and then for a side note, just to add to polygons, I just wanted to add something called the complex polygon. The complex polygon is simply more of a combination of different polygons with lines that do intersect. For example, 1, 2, 3, 4, 5. Here we have what looks like 1, 2, 3, 4, 5 triangles and a pentagon, and we have lines that intersect. Okay, so this can be classified as a complex polygon. We also have this one that across. I've seen this one before here. Okay, as long as I'm using straight line segments, it should be okay in the polygon category. Now what I would like you to do is create your own polygons, either both regular and not regular polygons. For a regular polygon, what you can try is folding a small piece of paper in half, and then the second time over here. And what I'm going to do is just do some random cuts and then open it up to reveal what might be a symmetrical shape. As long as I create these straight cuts, nothing curvy, I should be creating a polygon. Okay. Here's one sample, and if you count the number of sides, that's going to reveal what type of polygon it is. Here I'm looking at 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8 is 16. That's a 16-sided polygon. Let me fold this one even more. Give us straight cuts, no curves, remember, no curves. Open this guy up. Okay. This is a rather symmetrical looking shape, but I do have straight lines, multiple angles, multiple straight line segments. There's another polygon, very elaborate. And you can keep it as simple as this. Fold once. Actually, let me show you what's not a polygon. I've got this curve cut right here. That's automatically avoids the polygon label. Then I have a straight line segment. But because of that one curve, which actually doubles when you open this up, not a polygon. Okay. And last but not least, I'll just do 2 cuts. 1, 2. Open this up. Should be a quadrilateral. But because it looks like these angles are shorter or smaller and more closed than these 2 angles here, this angle, if it measures 30, this one will not measure 30, it'll measure something else. However, this angle should measure the same as this angle, and this angle down here has a opposite angle, has a matching angle over here. That's different from those 2. So that's not a polygon. No, that's not a regular polygon, but it is a polygon. Okay, that wraps it for now. That was a simple introduction to the polygon. Please enjoy the chapter. It's not too complicated once you take a look at the shapes and realize that the angles and the line segments and the lines that create the shape, the 2-dimensional shape, is what will dictate the category of the polygon and the name of the polygon. Okay. Thank you for watching.